I'm Jim Moulthrop, the Executive Director of FP2, better known as the Foundation for Pavement Preservation. And it's my pleasure to welcome you to the second session of the virtual National Pavement Preservation Conference. This session is focused on equipment you should expect to see in construction and common pavement preservation treatments. We have two session sponsors, Craftco and All States Materials Group. The session will begin with a presentation by Scott Bergkamp on control systems. First, a little background on our speakers. Scott Bergkamp is the president of Bergkamp Incorporated. The company designs and manufactures asphalt pavement preservation equipment. He's the immediate past president of FP2 and is active in ISSA.
So today, as Jim said, we're going to kick off with advancing preservation through control systems. Welcome to everyone, and I think I'll say it for everybody that we'd rather be live, but given the situation, we're going to do this virtually and have a good meeting. So today, when we're talking about control systems, to be clear, I'm talking about a control system for the pavement preservation equipment that includes a microcontroller or a microcomputer. It includes sensors that are gathering information from different functions on the equipment. It includes actuators that are controlled by the microcontroller, and then real-time processing to be gathering data, doing calculations, and making adjustments in real time. It may also include some communication with the outside world in real time. So that's what we're talking about today. So as I think about this, the goals that the pavement preservation industry needs to meet for agencies, as you can see right there, first, we need high quality application. When the project started, it's a continuation of a process that includes selecting high quality materials, having a mix design done, and so the equipment needs to function in a way that provides high quality. Of course, we also have to meet the agency specifications. The agency's gone through a process there of making sure that they've specified what they want. They have very precise ratios and numbers that need to be met. And so the equipment has to be able to do that, but also meet the agency's expectations that may or may not be written in the specs. So, for example, it could include reporting of the data at the end of the day, but what's the best way of doing that? So as I think about it, we talk about how the control system contributes to those goals. And today we're going to talk about the training. We're going to talk about simplified calibration. Of course, we're going to talk about quality, and then reporting and troubleshooting as well. And when I talk about troubleshooting, that can be troubleshooting of the equipment or troubleshooting of the system using data provided by the equipment. So for starters, when we talk about training, since the control system does a lot more for you than it does in older generation equipment, more focus of the training can go directly towards the application, towards what the materials are doing, how they're interacting with the pavement, how they're interacting with the ambient conditions. And that's allowed by, again, the control system is going to take care of a lot of calculations that can be very complex and required a lot of training time in itself. Since those are done by the control system, it's one less thing for the operator to worry about. It also helps in the training aspect of being in range or out of range. And my experience with this is when an experienced operator who is familiar with the entire system, the equipment, the materials, and the application process, can master that system and then say, okay, for this particular material, you've got a range of X to Y. And then he can tell that to a younger operator, a less experienced operator. The younger operator may think, wow, if I just turn this up even more and get past my limits, it goes easier for whatever reason. But by the experienced operator saying, no, stay in this range, and the control system provides the exact data they need to know where they're at in the process, they've got the data, they've got the wisdom of the experienced operator to say, no, I'm going to stay in this range, and I know I'm going to get a quality application. The other thing about the training is since these control systems use things we're very much familiar with now, touch screens and menus and joysticks, there's less training time needed to get used to construction equipment controls and being able to, for the operator, a new operator, to say, this looks familiar to me, I'm good with it. Okay, now tell me what I'm controlling and how it works. For calibration, as you've heard in in other presentations in the past and perhaps probably in the future, calibration is critically important, and we got to make sure the equipment is set up to do exactly what we want it to do. And so the first thing that an advanced control system does for you is it makes sure that you do a calibration. If there's zeros where it's looking for a scale factor, it's simply not gonna, there's nothing to be done by the control system. So it makes sure that the operator and the other people involved go through a calibration process and make sure it's got that data. The next two, I think, are the biggest things, and that's it's an automated process. And so calibration in the past could have been a written process in a manual or in a spec sheet. It could be following instructions on a spreadsheet that then requires the operator to do something on the equipment, record the numbers in the spreadsheet, and go back and forth. What the new control systems allow us to do is to automate that process. And the system is going to tell you what the next step is, what you need to do, and then it's going to wait for input from you. And so there's those few pieces of input that need to come from outside the equipment. As the operator follows through that automated process, it's impossible to skip a step. It's impossible to do them out of order. And so therefore it goes very cleanly quicker because the system's stepping you through it. Of course, when we do calibration, we talk about doing multiple runs for a given material, and that's so that by doing multiple runs, we can compare them to each other. If the first run was out of whack and it's the only one you did, you wouldn't have anything to compare it against to know that it's not right. Calibration has always called out doing multiple runs and then comparing them to see if they agree with each other. Well, in an automated system, it does that for you, and so you don't have to worry about an operator not catching it or skipping that step and just moving on to the next step and ending up with a scale factor that's not as precise as it could be. Again, it's a step that is done for the operator, and they don't even have to think about it. So it's simply the system will let them know if that's the case. And then the other thing we're seeing lately is that there are certain processes being done for pavement preservation and maintenance that are not calibrated at this point. They're simply operator judgment about how much material is going in. And so we're starting to see control systems being introduced for those processes as well. Okay, now let's talk about quality. Of course, in these processes, there's some calculations that should be performed, but they're very complex. They're very involved. It takes someone with a lot of training to do it right. So by automating those calculations and simplifying the process for the operator to only have to put in a few inputs, and then the system takes over from there, it makes sure that it makes it more likely that they're done. When something's very hard to do, it's very tempting to an operator to say, I'm just going to use the number I had last time. Surely that's close enough. But by automating those things, it increases the chances that they will be done as best they can. Another thing about ensuring quality is for those systems that have remote view that can be looked at from off-site on a computer or on a phone. It allows more people to be in the process of watching what's going on in a project and making sure that it's being done as best it can. And so, and this isn't just a case of someone watching over your shoulder, but done best, it's a case of bringing in other people with different experiences, with different training to say, hey, would you take a look at this, and does this all look right to you? Is this you got any advice for me? And so, and sometimes we look at that and go, you bet, that makes a lot of sense if my crew's working 3 counties away or 3 states away, but it can also make sense if you're very near the operation but need to take a look at it. If you look at this particular picture, this project, if someone wants to come up and take a look at what's happening on the equipment, they either have to cross traffic or cross a pass that's just been done or shout out to the operator and get limited information. But if you can pull it up on your phone, even if you're just standing right next to it, you can take a look at what's going on and then have a meaningful discussion with the operator because you've already know the parameters that are underway right now. A couple other things on quality. And so, of course, within a mix design or a job mix formula, there's generally ranges of ratios for materials. So it allows for some adjustability given the ambient conditions on the project site. If we talk about older equipment, an adjustment is made by pulling a lever or turning a knob or or changing a setting, a mechanical setting, we know we've made the change and we've gone in the direction that we want to go, but it's difficult to tell, okay, how far did we go? How much more material am I getting? How much did I increase the ratio? And without performance of manual calculations. So with these control systems, depending upon what the case may be, there's either you can set the ratio. For example, if I say I have a job mix formula that calls out between 0.4 and 0.6% mineral filler. If I'm running at 0.4%, but what I'm observing says I really need some more, in that case I can simply type in 0.5, hit enter, and that's what I'm going to get, rather than turning a knob and then watching it or having to do some calculations as the system goes on down the road. So it allows us to dial those in very precisely. For some components, it is adjustable. It's designed to be adjustable throughout the day because the conditions change. But in that case, there's a readout that tells you exactly what you're getting. And again, since we're doing real-time processing and getting feedback almost instantly, it lets us tune that in very quickly, know where we're at, and observe what the conditions of the field are after that. We talked about simplifying the complex before in terms of calculations, but there's also other operations and processes that difficult at times, and to the extent we can automate those with the equipment, it's simply one less thing that operator or the crew has to do. For example, an application rate. If it's performed manually, that means a person has to get a measuring wheel out and mark locations on the pavement and grab the numbers off the equipment at the right time. When this is done in real time, the operator can look and know where he's at all times. A few more things on quality, and since a lot of these pavement preservation treatments are done with asphalt emulsion, we know that the water content of emulsion will change by a few points just depending upon given conditions at the emulsion plant. And so if we're setting the equipment up based upon percent emulsion, the actual percent asphalt that we get will change a little bit as the residue in the emulsion changes. But if we set up to work on asphalt percent and know that when I get a new load of emulsion in, I can tell the system what the asphalt residue percentage is, it allows the system to fine-tune the process even more so that when the process breaks, sets, and cures on the road, the amount of asphalt that we end up with on the road is exactly what we want, rather than being having a little bit of variance due to the emulsion variance. The other thing that, since it's easy to display these numbers, to display the parameters in different configurations, we can get exactly the information that other people involved in the project may need at a given time. So, for example, the chemistry supplier may be interested in the percent of additives that's going in, and that number is immediately available. Whereas the emulsion supplier might be saying, "Hey, do I need to send you another load of emulsion today?" And the operator can look at his usage and know how far he's got to go, and say, "No, I'm good for today," or "Yeah, send me another one." So the information that's needed by different people involved with the project is quickly available. So when it comes to reporting, of course, the agency is going to want to know what happened on that project site for their road for that day or that project. And these control systems give us some options, and they both make a lot of sense. You could say that, okay, online's more advanced, gives us more information in the printout. Why would I ever want to print out? Well, we do have a case where perhaps the inspector on site has to fill out a daily report, and they'd really like to have the information immediately available right at the end of the day. And so with the system, you can do a printout of what's happened for the day, and they can include that in their report. Whereas the online might be more helpful for a project manager, for the contractor to know how his crew's doing, to know where they might need some input, and just being able to take a look and see what's going on. So the reporting options give us some options there about how to do it based upon what the needs of the person is. Of course, we also got the troubleshooting aspect, and so troubleshooting in case we've got a problem with the equipment or with the system. And of course, I think even if it's an equipment problem, the agency's got a concern about that everything gets back to working condition as quickly as possible, so as to make sure they're getting a good product, and also just to get the project moving as cleanly as possible. And control systems like this give you a lot of information as to what's going on. There's a lot of details as what's going on. You can look down to the level of what an individual sensor is reporting back to the microcontroller. You can get a look at what information is being sent to an actuator by the microcontroller. And so an operator can take a look at that on a phone call with a technician, so the technician knows exactly what's going on. They can report back the operator can report back what they're observing in the field. And then with that information, with so much more information available to the technician to do troubleshooting, they're just going to get to it more quickly, and be more confident of a solution. Of course, if the control systems includes remote view, then the technician can go dive into that stuff themselves, while the operator is taking care of other things if that's necessary. And again, get to a solution that's to get them back up and running very quickly. If it's a system problem, it might be that we need to look at the materials and how the materials are cooperating with each other. And again, this type of control system can provide a lot of information to help work our way through that. As shown, we talked about how about calibration, quality is affected by control systems, how reporting can be, give us some more options of reporting with these control systems, and how it can help in the troubleshooting aspect as well. So with that, I thank you for your time.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.